Well, hello there, everyone. Yeah, this is KP the Map G, and let me shut this door right here. Okay, my wife's in the other room working, and I don't want to interrupt her. All right. Yes, I'm sporting a hat. That's probably what I wear a lot when I'm either fishing or farming, one of the two, and I kind of like it a little bit. So anyway, be that as it may, it's been through the mill. By the way, it's been tossed into the river one time when I was trout fishing, and I fished it out. Of course, I cleaned it. Okay, I cleaned it since then, but oh boy, it's been through the mill. So if it looks kind of, like it's mashed in a little bit, it probably does look like that. So okay. Probably is. Alright, we are looking at properties of e to the x, ln of x, and a to the x. And I wrote some things down the other day so that maybe we can get used to it. First of all, we want to talk a little bit about e to the x and ln x. If we were to, I'm just going to draw a rough sketch of this. Here's an XY coordinate plane. Now remember, anytime you want to figure out inverse of anything, you plot the graph. Well, I'll say almost anything. And it may be anything. I'd have to look that up, but you plot the graph, and I dotted it so I could show the difference in the two. Y equals x, and that's a dotted line, I know, but anyway. And y equals e to the x. E is a function, by the way. It kind of does this here, and it takes a dive up like that. Okay, rough sketch, very rough sketch. This goes through 0, 1, and this ln goes through 1, 0. So right there you can tell that is okay through 1, 0, and it does something like that. Oh no, it does not. It goes more like this. Okay, this probably shoots on up. Yeah, this does not hug to the line that much. It shoots up pretty fast. So on up like this. These are, in other words, if you were to fold this along the y equals x line, these are to coincide perfectly, and I know I didn't draw that anywhere close to what it should be, but they are. See, this is y is equal to ln of x. They're inverses of each other, which tells us one thing. There is a rule. I'll just put it down. Oh, I guess we can erase this. But that's how you do inverse. Alright, so that's the idea behind it. Alright, so let me erase this, and I want to put up a little rule for e to the x and ln of x, since they are inverses of each other. You see what happens, okay? Alright, here we go. Let's put this back up here. Alright, so okay, so if x, let me get another. If x is any real number, alright, then e to the x equals equals y if and only if. That means if and only if. ln y equals x. So, in other words, if we had, let's just turn it around, if we have y is equal to e to the x, then what we can say is ln of y equals ln e to the x, and all that does is the ln and the e both, I hate to say cancel out, but that's what happens with inverses. So we have ln of y equals x, and that's what we have here. Well, on the other hand, okay, so ln y equals x right here. If we take e to both sides right here, okay, so yeah, yes, we've got these going out, and y is equal to e to the x. Alright, and so that's what that simply means. They cancel each other out. They're inverses of each other, and I really, again, I hate to say cancel each other out, but they're inverses of each other. Okay, so ln knocks out e knocks out ln. Okay, let's go ahead and look at a couple of examples with this. Okay, bear with me. I want to try to stay on this side of the board. I can flip it over anytime. Okay. This thing has rollers, so if it rolls to one side, forgive me. Alright, now let me see if I can readjust that just a little bit. Okay, that's probably alright. Okay, let me say this. If we had, for example, let's say we had, if we had ln e to anything, we can make this the cube root of 2x plus 5 is simply just the cube root. Just drop it down on the ground, and there it is, 2x plus 5. On the other hand, if we had if we had ln, or even e ln of the square root of 9x minus 4, well, again, it's just the square root of 9x minus 4. So that's sometimes when you want to solve for a variable and you have ln, you can get rid of the ln by introducing the e. It just simply knocks it out. Okay. Another one real fast. E to the 5 ln x. You got to know a rule that says that a ln x is equal to ln x, bringing the a around, raised to the a. So this is equal to e ln x to the 5th. That just brings that over like that, and then that's just simply x to the 5th. So just a few things that you can do, a little preliminary stuff that you need to know when you're trying to deal with properties of e to the x and ln of x, okay, or ln to some function, okay. Okay, so that's that. All right. Okay, let me erase this. Matter of fact, I tell you what, we can go ahead and flip the board. I don't think we need to worry about erasing anything. Okay. Oops. Okay. Alright, there it is. Alright, a few theorems in place. This is just mainly review. This is things that you've had in probably even far back as Algebra 1, maybe Algebra 2. Okay. E to the A times E to the B is equal to E to the A plus B. And the same thing can be said of E to the A over E to the B, okay, is equal to E to the A minus B. So, well, I guess I should have, yeah. So if you're multiplying, oh, I'm sorry, that is, let me see if I'm doing that right. And that's, yeah, okay. Just want to make sure that that is correct, yeah. Alright, and then E to the A raised to the B is just simply E to the AB, A times B, whatever you want to do there. Okay, just a few little preliminary things that we have to do, and sometimes you want to have this looking like this, and sometimes you want to go backwards and have it looking like this. Okay. Alright, so that takes care of that. Just a little other quick thing we need to look at. If I have y is equal to e to the x, then, well, dy over dx is still e to the x. The derivative is itself. Okay, so that's one thing that we have to remember there. Okay, so, alright, so that's that one. And then another thing that we need to look at is that if y is equal to ln of x, then y prime or dy over dx is equal to 1 over x. And then, of course, by the way, if there is, okay, prime, so whatever the derivative of that is, that's what we're having to do there. So those are a few things that we need to kind of keep in mind. All right. We will get to the A in just a little bit, but right now we're concentrating most of our effort on ln and E. Okay, let's look at a couple of examples where we find the derivative with E or maybe even with ln. Yeah, okay, so let's do that. And then we'll end up our discussion talking a little bit about the, a to the x or something like that. So a is not like, it's a, it's a constant or something like that. It's a number. Okay. E and ln are functions, but a itself is a number, like 3 or something like that. Okay, let's look at some derivatives. So if f at x is equal to x to the 6th e to the 4x. Okay, let's look at a couple of derivatives here, and then we'll probably bring our lesson to a close. 2 or 3 derivatives. Alright, so let's find, we want what f prime of x is. Okay, this is the product rule. Okay, so it is the first times the derivative of the second. Now again, e to the 4x, and again you still got to apply the chain rule to the 4x. So the derivative of, so again the derivative of 4x right there. Okay, so we had to just write the first one down, and then this is the derivative here. We haven't really taken the derivative of 4x yet, but we are on the next step. Okay, so the first times the derivative of the second plus the derivative of the first times the second. So 6x to the fifth, and then just simply copy down e to the 4x. We still got another step here, so this equals x to the sixth, e to the 4x, and then this derivative is, as you know, it's just 4. Alright, and then this plus 6 x to the fifth, e to the 4x here. We could put a 4 here in front, just kind of clean it up a little bit. E to the 4x plus 6 x to the fifth, e to the 4x. And I'm just going to leave it like that. You could factor out a 2. You could factor out a 2. X to the fifth, e to the 4x if you wanted to. So we could do that. I guess we could go ahead. 2 goes into both 4 and 6. Alright, so x to the fifth, e to the 4x. And sometimes, the reason I'm doing this is sometimes in a multiple choice answer may not be written like this, but it's probably written like this. 2 times 2 is 4. One more x. We don't need a, that's already taken care of here. Plus, alright, 2 times 3 is 6. And that's it. So it may be written like this. Okay. I thought not to do it at first, but then again, it may be written like this. So that is the derivative with an e function in it. Okay. Let's go ahead and do one with an ln. All right. Okay. There's that one there. Erase this. Okay, here we go here. Okay. I have an E on this one, but we can change it to ln on this one. This is okay. Given that g at x is equal to, instead of E, I'm simply going to do ln. We'll do that. And then we'll say this is the square root of 6x squared plus 5x minus 1. Okay, and I want to find g prime at x. Okay, it's ln of something. Okay, so remember that if we had y is equal to ln of x, then dy over dx is equal to 1 over x times that. Okay, so we have to remember to do the derivative of whatever this is. Alright, so this is what we're going to do. I'm going to erase this again. Alright. So the first thing you want to do with ln is you want to make it 1 over that without the ln symbol. 1 over, alright, the square root of 6x squared plus 5x minus 1. That's the square root symbol there, all the way across there. Alright. Okay, it looks a little better. But now I want the derivative, okay, of all of this. So I want the derivative, all Alright, I want to take that derivative. Keep in mind that we can rewrite this problem. Alright, so this is actually g prime at x is equal to 1 over the square root of 6x squared plus 5x minus 1. I want to get the derivative of this, but I'm going to rewrite it first. 6x squared plus 5x minus 1. Remember, this is 1 over 2, the exponent over the index, so we could automatically a square root can be written as 2 to the 1/2. And remember, we are taking the derivative of that. We have not done it yet. We're going to take the derivative of that now. Okay. Alright, so let's do that. G prime at x is equal to, again, just recopy this. You got this already in your hip pocket, so just copy it down. Now the derivative of this requires the chain rule. So remember, we're going to take the 1/2, all of this, 6x squared plus 5x minus 1. Now we've got to subtract 1 from 1/2, so 1/2 minus 1 is the same as saying 1/2 minus 2/2. It's still 1/2 minus 1. I want the denominator. If it's been a 1/3, I would have had 3/3 up here. If it's been 1/4, I would have had 4/4 over here. I made it a 1, and so 1 minus 2 is negative 1. So this will be a negative 1/2. Now, times the derivative of this, we're going to go ahead and do that. 6 times 2 is 12, so 12x, okay, let's see, plus 5, and remember the derivative of a constant is 0, so we can just stop right here. Okay, another thing about this one here, there is a rule up here that says that if we have a to the negative n, that's equal to 1 over a to the positive n. This is the part, let me get a different color, but this is the part right here that I want to sink to the bottom. This is already at the bottom, the 2's already at the bottom, so the only thing that's at the top is 1 times it. This is over 1, y'all. So this 12x plus 5 stays up here. 12x plus 5. And then we have a square root of 6x squared plus 5x minus 1. And by the way, this is times 2 now. Okay, the 1/2, the 2 goes in the bottom, in the denominator. That's where the 2 comes from. Now we're going to make this to the positive n. Okay, so 6x squared plus 5x minus 1, okay, raised to the positive 1/2, which, by the way, let's just look at that again. A to the 1/2 is equal to the square root of a. Alright, so we can just rewrite this as a square root. Wow. Now look what we got here. I'm going to, let's see. I may just flip this thing over to look at it. Let me write it down on a sheet of paper, but we have a square root of a times the square root of a. We got a 2 in there. We can put the 2 in front. But in this case, that's what we have. I'm going to put the 2 out in front. And we got this, this should be minus 1 right here. Minus 1. Now, there we go. This is exactly the same thing here as it is here. Okay, so the square root of a times square root of a is the square root of a squared, which is just a. So all we have here, maybe we can squeeze this over. So really we got 12 12x plus 5 over, let me scoot this over where I can get in here. Okay, so over, alright, so this square root times this square root just knocks off the square roots. Alright, so that is just going to be 2. I'm going to put the 2 out in front. So 2 times 6x squared plus 5x minus 1. That is it. And remember, I can multiply the 2 by all of this. That's fine, but I'm just going to leave it like that. Okay. In factored form. Okay, I can leave it out like that. But if you want to, 12x squared plus 10x minus 2, if you want to do it that way. Alright, so that is, I think that's really what we'll do. I think I'll hold off on the A problems and I'll do a couple of examples of that. But you got an idea of the inverse, that E is the inverse of Ln and Ln is the inverse of E. You have the idea behind what the derivative of e to the x is and what the derivative of ln is. We'll probably, in the next section, I'll probably do another couple of examples there, one with e and one with ln. But suffice it to say, this is what I wanted to cover at this point in juncture. I guess I'll hold off on the a to the x for another time because I did spend quite a bit of time on these problems here. But needless to say, this is it, what we have here. Very, very good problem, okay, but it just takes a little practice to get used to doing things like this. But you'll get it. You'll get there. Alright, so once again, I appreciate you and your attentiveness to this and dealing with me patiently, because sometimes I take my time, and I do like to take my time doing this. As you can tell, I'm probably not as I probably don't have the technology that some others do have. I just have a plain whiteboard and a bunch of markers here, and I do the best that I can with what I have, and I don't worry about what I don't have and what I'm unable to do. But I do wish I had other things, but maybe at a later date I can, and maybe have somebody show me how to do those things. But there again, if you see that subscribe button, please press that subscribe button. I appreciate that very much. Again, signing off, this is KP the Math G. Have a nice day.